What's up, guys? In this video, I want to go over an easy, medium, and hard example of how to write the equation of a polynomial when given your zeros. Typically, the easy is going to be something you'd see on your notes from your teacher. It's more introductory. The medium is going to show up on quizzes and tests and homework. And then the hard is where I like to highlight a lot of the mistakes that students are going to make. So let's go and start with the easy example. Okay. So again, we're going to be writing the polynomial given the zeros, okay? So we have a zeros of 0, 5, and -7. Now in this example, I have m equals 3. Now what does m equal 3 represent? That represents the multiplicity. So multiplicity just represents a repeated 0. And what that does is that tells us a lot about the behavior of how that 0 is going to cross the x-axis. Now we're not going to get into the graphing. We're just going to focus on writing the equation. But what I want you to think about is that multiplicity is also going to tell us what the power of our factor is going to be. So when you're given your zeros, the first thing I always like to do is understand that all these zeros, we can write them as x equals. Okay, so that's always going to be your first step. Take your zeros, set them equal to x. Now, what we need to be able to do is write them in their factored form. So if you have factors, right, and you apply the zero product property, you set them equal to 0, and then you solve, and that's how you get these solutions. So basically what we're doing is we're just working our way backwards. We want to take these where x is equal to, and now what we want to do is set them equal to 0. So to do that, I'm going to add a 7 to both sides. I'm going to subtract a 5 to both sides. And this one, you can think about this as subtracting a 0 to both sides. Now I'm going to have them written all equal to 0. Now, technically, you don't need to do all this extra work here. I'm kind of doing it just as a math teacher to kind of show you and explain, because when I have this expression set equal to 0, these are going to be our factors. Now, before we go ahead and start writing things in factored form, we want to remember what exactly that multiplicity is going to do. The multiplicity is going to tell us the power of our factor. So remember this 0 had a multiplicity of 3. So what I'm going to do is I'm going to take this and write it in factored form and put it to the power of 3. The rest of these are all going to be to the power of 1. You don't really need to write the 1 though in that case, but I want you to see when you have your factor equal to 0, these are now going to create our factors. So I'm going to introduce the equation y that's going to be the set of these. Do you really need to write x minus 0 cubed? No, you can just write an x cubed. Okay. So now I have it in its factored form, or written as a product of linear factors. And now to just go ahead and write the equation of the polynomial, I just need to multiply everything out. I see these two binomials, right? I can use FOIL or think about it as distributive property. I can multiply that out quickly, and then I can just go ahead and multiply by an x cubed. So let's go ahead and multiply here. So x times x is going to be an x squared. Here I'm going to do these together. X times 7 is going to be a 7x. -5 times x is going to be a -5x, so that's going to add to a 2x. And -5 times a 7 is going to be a -35. Now, all I simply need to do is multiply my x cubes times everything, and we'll be good to go. And there you go, ladies and gentlemen. You can see now a quick little way you can also go ahead and check your answer is take the number of zeros plus your multiplicity. That should be the degree of your polynomial. So I have 3 zeros, but this one's repeated 3 times. So this is technically like 3, 4, and 5. And you can see we have a polynomial to the 5th degree. So we are all set. All right, now let's get into a medium example. Okay, so again, we have our lovely multiplicity, but in this case, we have a imaginary 0. So we have a 2i. Now, what's really important about this is we need to understand the conjugate is always going to be there when we have irrational as well as complex solutions. And again, if you just think about this, if I was looking at this like an x squared is equal to, let's just say -1, right? You take the square root. Well, remember, when you introduce the square root, what you're going to do is you always have to include the plus or minus of that solution. So that's why we have plus or minus I in this case. So whenever you have a positive 2i, you always have to include a negative 2i. And that's also going to be true with irrational solutions. Whatever you have to introduce the square root to be able to get those solutions, you got to make sure you have the conjugate on. So I know I'm going to have x equals 2i, right? We're going to set everything equal to x first. So I have x equals 2i. I know I have x equals a -2i. And then I'm going to have a x equals a 4. But again, we're going to raise that to the multiplicity of 2. Now, let's go and write them as set equal to 0 so we can identify what the factors are going to be. Okay, So you can see, like, I'm just putting parentheses around here so you can see what the factored forms are. But all I did was like subtract 2i on both sides, added a 2i to both sides, and subtracted a 4 just remember this has a multiplicity of 2. So I'm raising the factor to a positive 2, not raising the x squared, right? Because that would be a completely different 0. You got to take the factor and then raise it to your whatever your multiplicity is. Now you guys can see that I have everything in factored form, so therefore I can set it equal to y because that's what we're trying to solve our equation for. You could also use f of x depending on the directions. Okay, we're probably going to want to utilize some special factoring techniques in this case. Hopefully you recognize that this is an example of a difference of two squares, and this would be an example of a perfect square trinomial. So remember, a perfect square trinomial, you're going to square the first term, square the last term, and then you're just going to multiply by 2 the product of your first term and your second term. You could also expand it out and do FOIL or distributive property, whatever works for you. For either one of these, you can do the exact same thing. But remember, the difference of two squares, that's going to be a squared minus a b squared. So that's going to make my life a little bit easier here. So if I multiply this out, x squared, or my first term squared would just be a x squared, and then my second term would be a 2i squared. So a 2i squared is going to be a 4i squared, and remember, I squared is equal to a -1, so we'd have an x minus a -4. Right? And then you can see that's how I'm going to get to the x plus 4 is my answer. And then over here, I can multiply this out to be a x squared, and that'd be a minus 2, so -8x, and then plus a 16. So I'm going to go ahead and rewrite this as a positive 4, because now I need to multiply a binomial times a trinomial. And ladies and gentlemen, you can go ahead and apply distributive property if you like to. I'm just going to tell you from experience, I see more students make mistakes by trying to use FOIL when we're multiplying polynomials that are larger than a binomial. So what I always like to do is I just like to create a box. It takes a little bit more time, literally like 2 seconds for me to draw the boxes. And then I just take my one polynomial and I write it along the edge. And I take my other polynomial and write it along this edge. Now, if I'm multiplying these, all I'm simply going to do is multiply the length times width for each of these boxes. And that's going to give me the total area, which just represents the product of these two binomials. So x squared times x squared is x to the 4th. X squared times a -8 is 8x is a -8x cubed, and x squared times 16 is a positive 16x squared. This is a 4x squared. This is a -32x, and this is going to be a 32. That's going to be a positive 64. Now I can combine like terms on my diagonal, and I get a final answer of y equals a x to the 4th minus a 4x squared minus a 16x plus a 64. All right, now let's go and get into the hard example. But to do that, I ran out of space. So I'm going to go ahead and erase this and then go back again. Okay, so now we're on to the hard example. And again, this is the one that I hope you know, if you're kind of struggling a little bit, a lot of students will make mistakes in this case. And I'll kind of try to highlight as many areas where I see students make the mistakes. But again, the good thing is we don't have any multiplicity, so that's kind of nice. But the process is exactly the same. Now, the only difference here is now we actually have a point that's on this polynomial. So that's going to help us be able to identify exactly the true case of what this polynomial is going to be. Because technically for those other two polynomials, there could be variations of it with a stretch or a compression. So this is going to identify the polynomial that has to go through exactly that point. All right, but let's go through the steps just like we did with the other ones. So I'm going to write all of my zeros set equal to x. So I have x equals a 2/3. Here I have x equals a 1 plus a square root of 2. Now, here's where a lot of students will make mistakes. They will forget that irrational zeros have your conjugate, right? So if square root of 2 is 1, then also a negative square root of 2 is going to equal 1. So the conjugate in this case is going to be a 1 minus a square root of 2. Sometimes students will negate both of those. Don't do that. We're just negating the square root because that's where that comes into that plus or minus. Or sometimes a lot of students will just forget it altogether. So we have our zeros. Now let's go and set them equal to x. So again, in this one, a big mistake that students will do is subtract 2/3, which is technically not wrong. But my problem with that is it's just going to create more fractions. And if you are like majority of my students or like myself, you make mistakes with fractions. So what I'm going to prefer to do is multiply by 3 on both sides and then subtract a 2. So therefore, I'll have a 3x minus 2 is equal to 0. Over here, again, students try to do everything in their head and they make mistakes. You're going to subtract a 1 for both of these, but then you minus a square root of 2 and you add a square root of 2 on both sides. Okay. So now I have everything written out as equal to 0. these are now going to be my factors. We're not going to worry about this f equals 1 just yet. We'll get to that in just a second. You could actually compute it in this case, but I always like to simplify everything first. In my opinion, I think it just makes it a little bit easier. So I'm going to have my y is going to equal to the product of all of this. Okay, I realize, ladies and gentlemen, this could look pretty daunting for a lot of students. In this case, I have a trinomial times a trinomial. Mr. McLogan, I use the box method. That's going to take me forever. Yes, I agree. It can. So what I would do in this case is I would look at this. If you group these first two terms together with parentheses, what I want you to recognize is this can also be written in the form of a difference of two squares, a minus b times a plus b. So therefore, I can actually simplify this down one more time to look like this. Okay, so if I multiply this back out, I'm now going to have this as an x minus 120 squared minus a square root of 2. Well, if you multiply this, yeah, that'd be a squared minus a square root of 2 squared. Yep, there you go. Okay, so now this is a perfect square trinomial. I should be able to multiply that out rather quickly or expand that out. And then the square root of 2 squared is just simply going to be a 2. So when I go ahead and do that, I get a 3x minus 2. This is going to multiply out to a x squared minus a 2x plus 1, and that's going to be a minus a 2. That can now simplify to a negative 1. So I'll just rewrite that right there. And now, again, we have a binomial times a trinomial, which, ladies and gentlemen, is not the worst case scenario. So we can easily just go ahead and do the exact same thing we did before. Let's go and do it over here. So let's go ahead and do. Okay, now again, just go ahead and multiply your length times width to go ahead and get each one. So 3x times x squared. Okay, there we go. All right, so I definitely made some mistakes. I had the minus 1. I didn't carry that back over. And then I multiplied these back through. That was supposed to be a negative 2x. I made some mental calculations. I needed to go back and check my work. So I have y equals a 3x cubed minus 8x squared plus x plus 2. Okay, that is our polynomial, right? That's what we did in those last examples. But what do we do about this? Well, this is giving us a point. It says when f of 1 is equal to negative 1. So what that tells us is when our y value is equal to a negative 1, our x coordinate, or our input, is going to equal to 1. So what that means, though, if I remember what I told you in the beginning of this problem, is that we can have a stretch or a compression. So what we can do is we can rewrite this. Actually, let's just rewrite this problem. I can rewrite this problem in terms of f of x, right? Because that's the notation we're using. And I can have a stretch of a. A is going to vertically stretch or compress the graph, right? Or reflect it. So it could be a times a 3x cubed minus an 8x squared plus x plus 2. I just don't know what that a is going to be. But again, even if you have a, that's not going to change the zeros. All that's simply going to do is, stretch or compress the graph. But I do know that f of 1 is equal to a negative 1. And I know that my input value is going to be 1. So what I'm simply going to do is just replace my x's with 1s. And then I can go ahead and solve for a. So I have a negative 1 is equal to a times, let's go here. So we have a 3 minus an 8, which is going to be a negative 5, plus 1, which would be a negative 4, plus 2, which is going to be a negative 2. So then divide by negative 2, divide by negative 2, and I'm going to get a is equal to a positive 1/2. So now, going back to my original equation, which I had right here, I have y equals my a, which is going to be my vertical stretch, or actually compression, times a 3x cubed minus an 8x squared plus x plus 2. And now, ladies and gentlemen, I can distribute that to everything to get my final equation, which I'm not going to use f of x. Let's go ahead and use, or y, I'm going to use f of x. And that's going to be a 3/2 x cubed minus 1/2 times negative 8 is a negative 4 x squared plus a 1/2 x plus 1.